name is Lloyd Walker. I'm part of Team 10 for the 1 Month Project. I'm here with Tyler Daugherty, Lizzie Payne, Chris Lane, and Henry Anthony. We're here to present our preliminary design review. And, like I said, so for the presentation outline, I'm going to start off with the introductions and the mission summary. I'm going to then hand it off to Tyler, who will talk about the electrical components and the trade study. Who will then follow by Chris and Lizzie talking about the mechanical and our descent system. And then finishing off is Henry talking about our software flowchart. And I'll wrap up the presentation with our hardware costs and conclusion. This is how our team is actually broken down. Evan Tingley is our team mentor. Chris and Henry are actually part of the software team. Tyler and I compose of the electrical team, and Lizzie is all alone in the mechanical. Alright, so the mission summary for the 1 month, as most of you all know, it is pretty much just a training balloon sat. It's going to communicate the ground station through an XB radio, and LEDs are going to be blinking to show flight state indicators. And also, the telemetry is going to send down our pressure, or our altitude measurements that are based off our pressure and temperature sensors. Then at a set altitude, somewhere between 600 and 700 feet up, we will release from the balloon and begin our descent, which will be through a parachute. And then once we land, we will have a buzzer that will assist in recovery. Here's our ConOps, our concept of operations. As you see in flight state 0, we are waiting for launch. Our LEDs blink at a low frequency. We are still sending telemetry. And then it will transition to the ascent stage, where our LEDs will change frequencies to show that we're going up. We will continue telemetry, and this is, as requirements, kind of measured around about 30 feet. Then we will have our apogee, or the highest point we're at. We will have a release. It's when our parachute will deploy, and like as requirements is between 600 and 700 feet. During our descent stage, our LEDs will blink at a different frequency to show that we are falling down and for some sort of visual indication. And then we will land somewhere, and we will try to find it by having, once again, blinking LEDs at a different frequency and an audible beacon, and we will still continue sending telemetry like all the other stages. And now I'm going to pass it off to Tyler, who will talk about the electrical components and our pressure sensor trade study.
All right, so our pressure sensor, we're using the MS5611, which we'll go over more in the trade study on the next slide. We're using Cree XBD LEDs, which were recommended to us pretty early on in the project. They've 97 lumens, so it's pretty bright. Shouldn't have any problem seeing it at the 2,000 feet. Pick green. It's highly visible at night. Figured it would be a little easier than a red or blue. Using a piezo buzzer, sounds off at 85 decibels. Having that 6 volts, should be able to hear that just fine. NTC 50K thermistor. We're using a servo and a 3D printed latch instead of a hot wire for our cut down. We have two 3-volt Surefire batteries, 5 and 3.5 voltage regulators. We've got a MOSFET hooked up to our LEDs and our buzzer. And then we've also got the exploit board, the XB radio, and the RBF pin. All right, so we had 2 choices really here for the pressure sensor. They were both pretty similar. We ended up going
grams total for our explained radio, BCD boards, sensors and indicators, total 9 grams, electronics 51. The mechanical release is estimated at 22, parachute at 18, and the case at 50 grams. That left us with a subtotal of 197 out of the 227 we were given as a limit, which gave us an excess margin of
software flowchart is mostly set out in the requirements for 1 month. All the breakout conditions for the while loops, what the LED should be set to when the buzzer enables, and what the telemetry sends are all set out. That said, a couple things I would like to mention: the LEDs are actually set outside of the while loops due to the fact that they will be set off of the clock cycle of the CPU on the MCU. That means if I do not need to put them in the while loop, if I do, I'll just be telling them something that I know every couple milliseconds. Also, the telemetry is between the get altitude and the judging of the altitude versus whatever our stop condition is for that particular flight state. This is due to the fact that I want to, at the very least, send a message on what our altitude is before we go into that stage, just in case something goes wrong. We at least know where it went wrong along the flight path. Other than that, again, everything is basically set out in the requirements for 1 month, so it's nothing else really to talk about. And now, Lloyd, finish.
And I'm back. Here to talk about the hardware budget. For most of the parts we had actually had to source ourselves. The total came out to be $48.54. That actually does include the ripstop nylon and our pressure sensor, which now known as actually provided to us. But the total comes under the required $50. And furthermore, adding in the provided parts are X-Plane, XB, and the batteries, and the total comes out to be $134.77. And then, kind of in conclusion, the preliminary design is complete. We still have to further refine and develop our software, and also our integration and testing. We have all of our parts in. We just, preliminary layout is done, but we just need to now stock them and do testing as well for each of the components, and as well with the code to make sure that they will perform as required. Another action item that we need to be completed is the parachute fabrication. We have the area and we have the materials. We just need to pretty much sew it together. So for our completed items though, everything's selected. We have everything in hand. We're just ready for final assembly and testing. And thus concludes Team 10 preliminary design review. And I can take any questions at this point. Yes, Jeff.